Okay, now we're going to go through chapter 7 worksheet 1. Okay, I'm currently on page 5. So in the past few lessons we have already discussed the things like what is the first term, okay, and we also discussed things like constant common differences. Okay, we also talked about how patterns, we have powers of 2 patterns, we have powers of 3 patterns. Okay, we have also discussed very briefly on example on page 5 the last time. Okay, now let's look at this sequence here. So a sequence consists of numbers with a rule that defines this sequence. So the rule here, as you can see, it is from 2 to 5, I plus 3, plus 3, plus 3, plus 3. So it is clear that the common difference here, it is a plus 3. Okay, now if I were to write it out in this form here, okay, I look at my first term, 2, look at my second term, 5, 8, 11, 14, and we know that from one term to another, I've always plus 3. So if I want to write it in this form, the first term, I will have my first 2. Now my first term has no 3, so it's 0 times 3. Second term, I of course start with a 2, but then I added a 3, 1, 3. The next term, term 3, I have a 2, and since I added a 3 from the previous term, I now have 2 times of 3. So here, obviously, this is 3 times 3, 4 times 3. So I want you to draw a pattern between the terms number as well as how many 3's I've added. Here I have 2, this is my second term, term 2, but I have 1 3. Third term, term 3, I have 2 3's. Term 4, 3, 5, 4. Now, so what can we notice? We can always notice that from the term number to the number of 3's there are, it's always a 1 minus 1 equals to 0 situation. Here, 2 minus 1 equals to 1. Here, 5 minus 1 equals to 4. So if I look at this number n here, can you then tell me how many 3's am I expected to get? I of course will expect to get n minus 1 number of 3's. Okay, so from looking at the pattern above, we can infer that Tn is actually made up of 2 plus n minus 1 times 3. Now, of course, after we have learned algebra, we know that we cannot just leave things as it is. We must expand it out 3 times. Okay. Okay, give me a moment, my iPad is lagging. Okay, so where was I? So after looking at this pattern here, okay, I will have 2 plus n minus 1 times 3. And we all know, okay, that we cannot leave answer as such. Okay, I must expand it out, getting me 2 plus 3n minus 3. Bring all the 2 and minus 3 together. Answer is 3n minus 1. Now, how to check during the exam would be when you sub in. Let's sub in 4. I will have 3 times 4 minus 1. Press calculator, I will get 11. So Tn here is now T4 because I get n to be 4. Sorry, when sub in n equals to 4, I'll get T4 equals to 11. So I check my term 4. My term 4 is here. Is it equals to 11? Yes, it is. So I 100% am confident that Tn is 3n minus 1. Okay, so over here, example 4, same thing. Okay, write down the next 2 terms of the sequence. I know that from here to here is a plus 8, plus 8, plus 8, plus 8. So the next term must be 30 and 38. Okay, so over here find the nth term of a sequence again. Okay, so I will for this part here, let's see. So previously I have the 2 here, and the 2 is always at the start. So I can infer here that my first term here will be the first number here, minus 10. Then plus what? Plus how many times of 3? Now where did this 3 come from? This 3 comes from as a difference from one number to another. Okay, so this must be a plus 3. And the inside, of course, if you want to generalize it, it is n minus 1. Okay, so what can we infer from this example also? What I can infer from this example is that the formula, when there is a constant difference, is always given to be a plus d times n minus 1. Now, this formula here you need to memorize. Tn equals to a plus d times n minus 1, where a represents your first term from the very first alphabet, letter A. So A here represents your first term in the sequence. And in my sequence here, the first term just so happens to be negative 10. Now, what is then D? D is then talking about the common difference. Okay, now the common difference here can refer to a positive or negative number. But because I'm going from each term, I'm adding 8 each time. This time round, my common difference here must be a plus 8. Oh, so here has to change. Plus 8. Okay, and n minus 1, it is fixed. It's always n minus 1. Okay, so after looking at this, again, what I want to do is I want to expand this out. Minus 10 minus 8, negative 18. So this is my term for Tn. Next, they want us to find that 50th term. So 50th term is to find T50. So when n is 50, I will get 8 times 50 minus 18. Press calculator. I will get 382 as my answer. Okay, so over here this formula is very, very, very important. Okay? Can I? Okay, now let's move on. Now for example 5. Find a formula for the general term of the sequence 2, 7, 2 over 7, 6 over 10, 10 over 13, 14 over 16. Now, the question here never go and simplify the fraction for you. So that means this is a clue. It is a clue. So we must go and find out what the clue is. Now, if you straight away go and minus the values together, you will get, let's say, 6 over 10 minus 2 over 7. Okay, I press calculator, what do I get? I will get 11 over 35, 10 over 13 minus 6 over 10. We press calculator. So what I'm doing now is I'm trying to find the difference between the terms. Okay, then here I get 11 over 65. And then I try one more. 14 over 16 minus 10 over 13. Okay, I want to see a pattern here. 14 over 16 minus 10 over 13. Press calculator, I'll get, 11 over 104. Now, other than the fact that the numerator is 11, the denominators have nothing in common. There's 35 here, 65 here, 104 here. So then maybe I shouldn't look at the fractions as a whole, because over here, it doesn't give me a direct link to what the rule is all about. So instead, what can I do? Let's see what I can do. Let's study this pattern a bit more. So other than considering the fractions as a whole, let's split it up. Let's consider the numerator line. I know some of you instantaneously clicked it already, right? Why? Because here, From 2 to 6, there is a plus 4. Plus 4, plus 4. The denominator line, let's zoom in into it. Here, there is a plus 3, plus 3, plus 3. So what does it mean? Okay, we can observe that the numerator increases by 4 and the denominator increases by 3. Okay, so what we're going to do is we're going to write it out this way. So the numerator is 2 plus 4 plus 4 over 7 plus 3 plus 3, because it's plus 4 from the numerator plus 3 from the denominator from the previous term. So again, if I write it out here, this will be 4 times 2, 7 plus 3 times 2. Term 4, okay, will be 2 plus 4 plus 4 plus 1 more 4, 7 plus 3 plus 3 plus 1 more 3. This will be 2 plus 4 times 3, 7 plus 3 times 3. So previously we already discovered that this is actually 2 plus 4, and these numbers here are related such that the term number 3 minus 1 will get me the 2. Similarly, for term 4, it is the term number of 4 minus 1, and the denominator as well, so term of 4 minus 1, that will get me my 3's. So again, what I'm saying here is that this is 3 and this 3 is related. This 4 and this 4 is related. So it's tied to the term number. So for Tn, it must be Tn equals to 2 plus 4 times n minus 1, 7 plus 3 times n minus 1. Okay, and as good mathematicians, what do we always do? We always expand and simplify. And this will be my answer. Okay, we test it out. Okay, we test it out, we check. Okay, let's say I check for T2. 4 times 2 minus 2, 3 times 2 plus 4. I'll get a 6 over 10. Is my T2 6 over 10? Yes, it is. Right, my T2 is 6 over 10. So then I know that this term here is correct. Okay, now next one. Example 6. Okay, the nth term of a sequence is given by 2n squared plus 1. Write down the first 4 terms of the sequence. So I find the first term, which is my T1, second term T2, third term T3, fourth term T4. Okay, and this is when n equals to 1, n equals to 2, n equals to 3, n equals to 4. So all I have to do is to sub it into my general term. Okay, here I will get 3, here I'll get 9, here I'll get 19, here I'll get 33. So these are the first 4 terms of the sequence. Now, do I need to include a dot at the end? Okay, the answer here is no need. Okay, because they only ask for the first 4 terms. Okay, now next one. Okay, the first 4 terms of another sequence is 1, 7, 17, 31. By comparing the sequence with the sequence in part A, okay, write down in terms of n a formula for the nth of the sequence. For the nth term of the sequence. Okay, just let me include the word term here. Okay, so here I'll get 3, 9, 19, 33. Here 1, 7, 17, 31. And we can see that from these two numbers here, there is a difference of -2 for each term. Agree? So for my first part here, just now the sequence for the first sequence here is 2n squared plus 1. So what do you think I can do to get this sequence here? Obviously it must be -2 lah, right? So 2n squared plus 1 minus 2 Answer 2n squared minus 1. Again, we check. Let's say when n equals to 3, I will get 3 squared minus 1. Press calculator, you will get 17. And is your third term here 17 in the new sequence? Yes. So 2n squared minus 1 is correct. Hence, find the 38th term. Find the 38th term of the new sequence. It will be when n equals to 38, 2 times 38 squared minus 1. You press your calculator, you will get 2887. And this will be your answer. That is all. Okay, now for this homework here, can I get it in by Tuesday? Term 2, week 7, Tuesday. Okay, now next lesson when we come together again, okay, we are going to be talking about sequences, and we're going to be crafting out our own sequences together in class. Okay, so that will be something exciting. Okay, I've designed a very cute worksheet for it. So let's come together, okay, and then we'll learn from each other. Okay, I'll see all of you on Monday. Bye-bye.